Good morning. I would like to welcome everyone to our session. Today we will be speaking about modernizing cyber resilience. My name is Dave Stemerdink. I work as a pre-sales consultant with Cohesity here in the Netherlands. I see some customers over there. So you can ask them if I'm telling the truth or not after the session, right? Dennis, be kind, please. Okay, so some of you might know us, some of you might not. From a traditional security point of view, we are not a known name. We're actually complementary to a lot of the traditional security solutions out there, and for good reason. Because what we've seen is that the majority of focus around security has been focused very much about trying to prevent and detect bad actors from getting into our castle. Traditionally, we would do this by building a fancy castle. We would add moats, big walls to try and keep people out. But the issue with that is that your adversaries are always building new tools, new ways to breach your defenses. So it is not a strategy that is sufficient in today's day and age to protect yourselves from bad actors. And in some cases, technical controls are also something that are insufficient and simply don't work against a lot of the modern attack vectors, which often includes the human element. So we need to rethink this, right? Because day in, day out, we see examples where we fail to keep the bad guys out and wreak havoc on our organizations. In the real world, we already realize that there is risk, that incidents will occur. And in the real world, we think about, okay, what do we do when things go wrong? What do we do when my building is on fire? This is really where we start to mature to a different mindset where resilience comes into play. Obviously, we do our best to prevent incidents from happening, but we do realize that we need to have processes and solutions in place to deal with those incidents when they occur. And in essence, that is really what cyber resilience is all about. And that is exactly where Cohesity is adding value to organizations. So one of the key things when we talk about cyber resilience when it comes to IT is that there are some very big differentiators between a traditional disaster incident and a disaster incident that is a result of a cyber event. So with a large-scale cyber attack, typically it's very hard to identify directly, what's gone wrong. Obviously, you notice, my systems are offline. I can't get into my building. I can't use our communication systems. What is actually going on? How do we get to a state from not knowing what's going on to a state where we do understand what has actually happened and how our response should be? Another element that differentiates a traditional disaster from a cyber event is that the impact is often much more wide scale, right? It's not a data center that's gone offline. The attackers have actually targeted your entire infrastructure, and your backup systems, most notably, are also part of that attack. If we look at the current numbers in pretty much every cyber event, in 95% of the cases, the backup systems are an active target of the attack itself. So taking all of this into account and trying to get back to a state where you can resume your business services is far more complicated and takes a lot more time than simply, performing a traditional disaster recovery. And without really understanding it and recovering your systems, you will often see that you're reinfecting your environment, which causes even more disruption and downtime. And really that is where we need to look at this differently, right? The complexity of a non-malicious incident, however complex it already is much, much lower than an actual cyber incident. There are also other things to think about when we look at cyber incidents, which most notably also impact, what type of data was part of a breach. Quite recently, we've had a very bad event here in the Netherlands where a lot of clinical data was part of a cyber event, exposing hundreds of thousands of personal records, highly sensitive information. So when this happens in your organization, you will want to find out who was impacted, who do I need to inform to mitigate the impact of one of these particular events. So there is a lot more going on when we look at the requirements for building a cyber resilient environment versus an environment that can simply deal with a disaster. Even looking at the different malicious incident types, we can see that there is an evolution and there are different ways, methods, and tools being used by attackers to actually impact your business with different outcomes, right? In ye old days when we spoke about ransomware, it was very much about, okay, we'll have your environment scanned out, we'll encrypt your systems, and we will knock on your door and ask for some Bitcoin, right? Highly disruptive, very painful for an organization, but the impact really is still quite limited, right? You will have to pay the attackers potentially. It's going to have an impact obviously on your reputation, but it's still somewhat manageable. We can actually recover. This has evolved where they try and prevent companies from recovering by attacking the backup systems. Now that a lot of backup systems are becoming more mature and becoming more resilient to these types of attacks, adversaries have been looking at different vectors to cause maximum disruption. And this is where IP theft is coming into play. It is being used for several reasons. One of them is obviously trying to motivate a company to pay the ransomware fine by threatening to expose data to the dark web or just on the internet, or actually report you with government agencies and say, hey, this company has their data assets very well, we now have sensitive information. You should probably look at giving them a big hefty fine. In other cases, it is more state actor oriented, where they will try and steal IP to advance their own industries. And again, the impact here is growing, right? Because you're not just looking at financial impact, but also at the competitiveness of you as an organization, or as us as a country or a region. In these two cases, still the main motivators of adversaries is getting some form of financial or technological gain. However, this is not where it stops. In recent examples, what we've seen in Ukraine is that ransomware is not being used to disable systems and try and get a monetary gain out of it, but we can actually look at this as true cyber warfare where complete systems will be wiped out. All production systems wiped out, backup systems wiped out. And when that occurs, basically that means that you as a company or organization cease to exist. These attacks are also shifting and focusing towards medical services, towards government services, infrastructure services. So it's a big threat, particularly in today's days and age, where we need to look at how do we actually protect ourselves and how do we become resilient against these types of malicious attacks. When we look at this as Cohesity, we look at a resiliency maturity model. We can map this to NIST, to to MITRA procedures and patterns to help companies evolve and become more resilient. And basically, it's covered in 5 steps. First, we need to make sure, obviously, that we can protect all companies' data assets, to make sure that these assets are well protected in our systems. We want to be able to use these assets to help you identify, detect, and being able to investigate these. Another important aspect is being able to simulate and train recoveries so that you are prepared against impacts in large-scale events. And ultimately, we look at optimizing how we can use these assets by detecting and identifying data to make sure that it's not part of a breach. Obviously, this keeps evolving and new functions are being added, but at this moment in time, this is how we can help companies get to a mature model. And we will step into these in a little bit more detail, right? So when we look at protecting data assets, it really comes down to being able to protect as many possible different workloads and data assets across a company's infrastructure. Traditionally, that has been quite difficult because a lot of companies will use different tools, different assets to protect information assets that are sitting in a traditional data center or in a remote location or in one of the different hyperscalers or in SaaS services. Having all this complexity and disparate tools makes it very hard to have global insights whether or not your assets are being protected. In addition, we see that new applications and new services are being developed constantly. So we see almost 2 new applications and services being added on a weekly basis, being adopted by organizations. So we need to make sure that we can actually keep up with this evolution and keep all that data protected in our platform. This is something that we can actually do with Cohesity, so give customers a single tool that spans all their applications, all their different environments from a single UI with centralized reporting and insight to make sure that we can help companies protect their data assets. What we also see, obviously, is that as we are getting more popular with our customers, is that our systems are constantly being tested as well. So we are also assuming that even with all the safeguards that we put into place, at some point in time, our technology might be compromised, right? I can say that up until today, this hasn't happened, but on a weekly basis, we see that customers are being attacked, our systems are being attacked. And sometimes when configuration isn't right or procedures aren't right, there is an impact, but we have always been able to recover. New tools are being implemented as well. So AI is a big opportunity, but also a big threat, just because it's actively being used to try and breach customer and systems, and also our systems. So looking at this, we've recognized that there is a big need to also have isolated copies of data sitting outside of a customer environment in an isolated recovery area, where we can make sure that even in large-scale events, we always have a backup copy to get back from. In the old days, that used to mean that we would have a tape sitting in a vault somewhere, as our last strand of hope to be able to recover. The issue with that is, with the growing volumes of data, is you can only access those media types when you actually start to load those data assets back into some kind of environment, and then you need to start to investigate what's actually going on. Can I actually still use this copy? Yes or no? So we've actually developed a solution that gives you live insights into those isolated copies so that you can actually identify indicators of compromise. You can identify the health of a system to look at its patching level. A lot of added intelligence to help speed up recovery, even if you have to resort to that last copy that you have in what we call our cyber vault in either your data center or in a service that we can provide. The outcome here again is being able to recover quickly, increase your defense posture, and also looking at legislation that's coming into play with NIS2 and DORA, you can actually prove compliancy. So here in the Netherlands, it's still considered as an advisory solution that you need to put in place. If we look, for example, in Belgium, it's already been taken into as a law, right? So sometime in the future that will also happen here in the Netherlands, and then companies will have to adapt quickly to those new regulations. So that means that for government entities, critical infrastructure services, but even supermarkets and banks, they will need to have that isolated copy built out in their environment. And here is really where we start to get a tie into the more traditional security aspects. And that's being able to actually detect indicators of compromise, to detect what data assets are being compromised in an attack based on just your backup systems. This is all happening isolated, so it doesn't require any agents, external connectivity. We don't run these scans on your production systems. This is all happening on the copy of backup data that we have in our platform. This is quite empowering, because it means that if you get some early detectors in your network where you think, okay, there might be something going on, somebody might be snooping around in my environment, rather than actively hunting and trying to find the bad actors in your production environment, which could trigger a response from the attackers where they execute the kill chain, wipe your systems, or start encryption, you can actually run a forensic analysis in your backup system, right, without impacting production, being able to quietly build a response plan, and then once that's tested and validated in an isolated environment, roll out that response into your production systems. We can do this with technology that we provide ourselves, but we've also seen that customers typically have a lot of security tools already in place that they're accustomed to, that they want to reuse for this case. And that's also the reason why we've actually opened up our platform to be able to integrate with existing security tools that customers may have to really leverage that technology, make sure that security operators don't necessarily need to learn new tool sets, and also obviously control costs, because every tool that we introduce adds costs and complexity, and that's something that we want to avoid. Now, looking at best practices, it's great that we have a copy, it's great that we can detect things that when they go wrong, but how do we actually respond? How do we make sure that we can bring back a critical business service, which is typically a combination of different elements? You may have some parts of your application running on the web. You might have some application elements running in your data center. Database servers, application servers, web servers, you name it. It's quite complex to restore a critical business function. So with Cohesity, we're able to leverage the power of AI and machine learning and actively identify the relationships that we have between different elements to build out these applications, blueprints automatically, and have them updated automatically, where you can start to run your recovery tests, prove that you can actually recover a critical application, that you can recover to disparate environments, from on-prem to cloud, for instance, or vice versa. And also have reporting towards your board to make sure that you can actually prove that you can recover, which will also be an important element of NIS2 and DORA, because just having something on paper isn't enough anymore. When we look at this step of preparation. It is not just having that intelligence about how your applications work together, being able to restore them. What we also have identified is that in the worst types of situations, you will need to have some additional assets available, which could become unavailable. And that's something that what we capture in what we call a digital jump bag. So you can think of that as your go bag. In case of emergency, you can just pick it up, jump on a plane, go somewhere and do your job. Something similar is required when we look at a large-scale malware outage. So what is it that you need as a bare minimum, in addition to obviously your data, to rebuild the fundamentals of your organization? Things like copies of your software, right? Highly important. Having images ready, having your deployment automation tooling protected and available in a secure environment, having a Rolodex with people to call in the middle of the night, with their rules and responsibilities, with your response plan to certain situations, so that you don't have to discuss what you do when things are already really bad. So all this information is what we capture in something that we call a digital jump bag. We can secure that in our platform, make sure that we replicate that out into also the secure vaulting environment, for example. And then if all systems fail and you need to get to this information, the only thing that you need is connect your laptop to the system, access the jump bag, provide obviously the right credentials, and you can simply download this information directly. So there's really minimal effort required to gain access to this information set when things go wrong. And then obviously you incorporate that into your response plan. When we look at optimizing, right, and this is a highly important aspect as well, is actually identifying what type of information do I have in my various systems. Am I seeing overexposed data on a server or a file share or somewhere in cloud where it shouldn't be? What type of information is actually there? Is it PII data? Is it passwords? Is it keys, right? Is it banking information? Should it be there? Is that critical information actually protected in accordance to our comfort policies? If you don't know the data is there, you can't really enforce those rules. So again, we leverage the power of our platform to provide that level of insight into information, and then also tie that into a architected response so that we can add these critical assets into protection. If we identify that sensitive information is sitting somewhere on a system, we can fingerprint it and send it to one of our partners like Zscaler so that it can block any exfiltration attempts. Again, making sure that the exposure of your data is minimized and we can actually have the right response plan to it. Or if you're hit by a massive event, you know still what information is sitting on which systems to help you prioritize your response plan in accordance. So all these capabilities are what we add in a cyber resiliency maturity model together with our customers to help them recover when things go really bad, when they're hit by ransomware. It's not something that we do as Cohesity on our own. We have identified that there's a strong need from customers for different vendors to collaborate more effectively and join forces, because ultimately that's also what our adversaries are doing. And this is the reason why we formulated the Data Security Alliance about 3 years ago. And you can see that the key players in the different aspects are all present. It's not just something that we put on a slide, right, and say, hey, we're working together. When you go to the different marketplaces of either Cohesity or one of the vendors that you see here, you'll see that we have ready to go API level integrations built so that customers can easily integrate our capabilities into their infrastructure. I'll give an example with Cisco, for example. If their XDR, EDR solution detects that something is going awry on the network, it can actually notify Cohesity to create an immediate backup of critical systems. And whilst investigation and eradication is going on, we will keep protecting those assets continuously so that if the event propagates in the environment, the data loss is minimized. And once the issue is resolved through the Cisco platform, Cohesity will simply be notified, we're done. Go back and do your thing based on your normal schedules. As an example, right? I mentioned Zscaler. If we identify sensitive information, we can fingerprint it, send it to Zscaler, and prevent a system being used as an exfiltration point. All these capabilities are continuously being improved to help customers become more resilient. In the end, Cohesity is offering some very basic, some advanced functions to help customers, right? Speed is incredibly important in case of a ransomware event. Having faster access to data, being able to investigate different versions of backups actively without having to move data around saves a tremendous amount of time. We have built a very secure platform up until today, where customers are calling into our support desk on multiple times a week. We have still not lost any data during attacks. One of the ways that we help secure ourselves and become more proficient is also not just by building technology, but also implementing procedures like having a red lab, where we will basically take all the vulnerabilities and malware that we can find and unleashing it on our systems in a controlled environment, both for the solutions that we provide to customers, but also for ourselves as a company where we provide our services, to make sure that we stay ahead of the curve wherever possible and help evolve. Our scalability is again something that is highly valued by customers, where we can start in relatively small environments, but as companies grow, they don't need to reinvest or re-platform. So we can go from a few petabytes, terabytes, up until petabyte ranges in the same platform. So that really helps organizations. It's very simple. When you use Cohesity to protect your on-prem data assets, the look and feel and capabilities are exactly the same than when you're protecting assets in Azure, or if you're deploying Cohesity in Azure or AWS or Google. The capabilities are always the same. The reporting is centralized. Everything is simple and easy to manage, which means that you can do a lot more with fewer staff, which is a big issue. Then we're adding insights into data, or smarts, to help you identify indicators of compromise, to help identify critical information assets. And now we're also adding on AI services, not just from an operational point of view, but we're also integrating large language models with RAG capabilities into the platform, so we can actually add value to business services. So if you want to learn a little bit more, or want to have a demo, we can certainly facilitate that at the booth. If you want to hear some real life experiences, there's two gentlemen there who have been using us for several years. So I would like to say thank you for attending the session, and hopefully we'll be in touch. Thank you.